So here we have a connected particles question, and we're just going to read through and highlight some of the important information and try and produce a diagram as we go. We're first told there's a particle A of mass 800 kilograms is connected by a rigid bar to particle B, who has a mass of 1,400 kilograms. So I'm just going to label both A and B, and I'm going to put their masses on. So A on the right hand side, B on the left hand side. Well, A has a mass of 800 kilograms, so I'll just put in 800, whereas B has a mass of 1,400. Let's label that. And I'm told there's a force of 21,000 newtons, and that's applied in a direction away from B. Okay, so 21,000 Newton driving force. That means this whole system will be moving to the right. So we should really add a direction arrow to show us the positive direction. If there's a driving force, that means there's going to be some internal forces in that rigid bar. This driving force is going to produce some tension in the bar. These two tensions, one on A and one on B. We're also told there are some resistive forces. 540 is operating on A, 700 is operating on B. Okay, this is a complete diagram. From here, we should be able to solve for the unknown tension and the unknown acceleration. We should always then start with Newton's second law. We want a motion equation for each of these individual particles. We'll focus on A first, and we want to consider all the forces acting on A. As I look at my diagram, there are three forces to consider: the 21,000, the 540, and T. Now we need to use the positive direction, which is to the right, to decide which of these forces are positive and which are negative. 21,000 is the only positive, so 21,000, negative 540, negative T, and that equals 800A. Okay, now let's focus on B. All of the forces operating on particle B. There's only two of them. Once again, we need to consider which is positive and which is negative. Tension matches the positive direction, which is to the right. So we'll get T, subtract 70. Positive tension, negative 700, and that equals 1,400A. Okay, we'll add together all the terms on the left-hand side. That gives us 19,760. Add the terms on the right-hand side, we get 2,200A. The acceleration is 8.982. Okay, so three significant figures gives us 8.98. Okay, so we go ahead and substitute in that acceleration, we can calculate the tension. I'm going to put it here into this motion equation for B. So T minus 700 equals 1,400 multiplied by 8.982. Just keeping a few more decimal places to maintain the accuracy. Okay, rearrange and evaluate. So just into the calculator, and we get a tension of 13,275. Okay, so that's our acceleration and our tension. If we go back to the question, we're also told to find the distance traveled in the first 8 seconds. Okay, this is a constant acceleration question, a SUVAC question, so we'll go ahead and collect the relevant variables. We do not know the displacement, we're looking for that. We know the initial velocity was 0, it has started from rest. Final velocity we do not know. Acceleration 8.98. We may well use 8.982, and time is 8 seconds. We know it started to rest because we're told that when the force 21,000 is applied, it causes them to move with an acceleration A. This implies that it wasn't moving before. Okay, so let's try and find the displacement. Formula to use in this case, S equals ut plus half at squared. And we'll go ahead and substitute in. So the ut will just be 0, a half of our 8.98 multiplied by 8 squared, well that's 64, all into the calculator, and we get a displacement of 287 meters. And that's how far it travels in the first 8 seconds. Okay, so a connected particles question where we then use our acceleration in a constant acceleration SUVAC calculation. This happens quite a lot. There is a connection between force diagrams and motion equations and constant acceleration SUVAC questions. The connection here is the acceleration. If we're starting either with constant acceleration and we calculate that, we can then use that with forces and motion. If we're starting with forces and motion and F equals ma, we can then use that in a SUVAC question.